Part 2 of the arc length and sector area worksheet. In the first part we did arc length, and now we will do sector area. So the definition of a sector is a piece of the area of the circle. So in other words, this shaded portion right in here would be considered a sector. So previously for arc, we were only doing a piece of the circumference, but now for sector, it's an actual piece of the area of the circle. Now, once again, P is the center of the circle, and when you have an angle inside the circle with the center at the vertex of that angle, that's considered a central angle. So this angle right here, the measurement of this angle, is represented by the Greek letter theta. All right, so theta is just going to be the central angle. And just like before, if you go from the center of the circle to the circle itself, that distance is represented with the letter R. That is a radius. All right, so R is going to be the length of the radius. Okay, and of course you have one here as well. So the basic formula for the sector area of a circle, it's very similar to arc length. It's going to be the fraction of the circle times the area of the entire circle. All right, so these two items are multiplied by each other. And just like for arc length, the fraction of the circle is going to be determined by this central angle theta. So the greater that this angle is, the more area of the circle is, the more of the circle is swept by this area. So if this angle gets bigger, this area is going to be a larger portion or fraction of the circle. So this central angle theta is what determines how much of the circle, or percentage-wise, is covered. So if the angle theta, central angle theta, is in degrees, the fraction of the circle, it's the same as before. For the arc length, it's going to be theta divided by 360 degrees. Okay, because all the way around the circle is 360. And that's going to be multiplied by the area of the circle. And we know that the area of a circle is pi r squared. So this fraction is right here, and it is multiplied times the area of the circle. So that is the formula for sector area when dealing with degrees. Now, if the central angle is in radians, you still have the same numerator. The numerator is still theta, but instead of dividing by 360, you're going to be dividing by 2 times pi. 360 degrees equals 2 pi radians. That's the angle measurement of once around the circle. And that gets multiplied by the area once again. So that's going to be pi times r squared. Now, in this case, a couple items, or one item, is going to cancel. This is a numerator and this is a denominator. These are multiplied. So pi divided by pi is going to cancel. And in the numerator, we are left with theta times r squared. And in the denominator, we're left with 2. So this right here is going to be the formula for sector area when you are in radians. Okay, and this right here is the formula for sector area when you are in degrees. Now, if you don't remember this, you can still start with this basic formula, and you can still start with this right here, but the pi's are going to drop out, cancel numerator and denominator. Okay, starting with number 13, they want us to find the area of each sector and round your answer to the nearest tenth. So once again, that is just going to be 1 decimal. All right, let's look at number 13. The part of the circle we're trying to find the area of is in boldface. Okay, so it's going to be this sector right here that is in boldface. So the area inside here is what we're trying to find. Okay, and for, well, we'll start with the basic. Okay, we said the sector area is going to be the fraction of the circle times the entire area. All right, so the fraction of the circle when you're dealing with degrees, that's going to be theta divided by the whole circle, which is 360. Okay, theta is just the central angle, and that's going to be multiplied by the area of the circle, which is just pi r squared. Okay, so this angle right here, that is our angle theta. And we can see the angle theta measures 60 degrees. In place of theta, I'm going to write 60. And that's divided by 360. And that's times pi times r squared. R is the radius, starts at the center and goes to the circle. So this distance right here is going to be the radius, and that is 10 inches. All right, so for the radius r, I'm going to plug in 10. However, that's squared, so it's times 10 squared. Okay, now just like last time, I'm going to rewrite. You don't have to, but these terms are in the numerator. They are multiplied by this numerator. So I'm going to write 60 times pi times 10 squared. Okay, 60 times pi times 10 squared. Those are all in the numerator, and that's divided by the one denominator, which is 360. Okay, and now I am going to go to the calculator. I'm going to do 60 times pi times 10 squared, hit equals, and then divide by 360. Okay, and for this fraction, I get 52.359. Rounding to the nearest tenth, you look at the second decimal. If it's 5 or more, you round it up. So that is going to be 52.4. All right, the units on the radius were in inches, but the radius got squared, so the units are going to be inches squared. Okay, and that makes sense because the units on an area are always squared. Okay, please pause and try number 14 using the formula theta over 360 times pi r squared. All right, number 14, you can see this here in boldface. This is the sector that we're trying to find the area of. So basically, everything inside this portion right here. So for theta, that is this angle right here. That's represented by the Greek letter theta. That's 150 degrees. So since we're dealing with degrees, this is the formula that we're using. So theta is going to be 150 divided by 360 times pi times r squared. All right, we can see the radius. It goes from the center to the circle itself right there. So the radius r is going to be 3. All right, we'll do the units later. But in place of r, I'm going to put a 3, and that gets squared. Once again, these numbers out front are a numerator, so they're multiplied by this numerator. We need 150 times pi times 3 squared in the numerator. Okay, 150 times pi times 3 squared are all in the numerator. And the one denominator is 360. So it's going to be divided by 360. All right, so on my calculator, I am going to do 150 times pi times 3 squared, hit equals, and then divide by 360. And I get 11.780. Rounding off, we look at the second decimal. If it's 5 or more, you round it up. So 11.7 is going to become 11.8. And the units on the radius were in meters, but the radius got squared, so the meters get squared as well. And that is the final answer, 11.8 meters squared. Now, starting with number 17, they want us to find the area of each sector, but they say do not round. So once again, there's two items that you need to be aware of. All right, you want to leave pi alone. In other words, don't plug in a number for pi, just leave it alone and don't multiply it through. In most cases, you'll have pi in the final answer. And also, you want to reduce the fraction as much as you can. I suggest you do this before multiplying because in this case, the numbers would be smaller and it's easier to reduce top and bottom when the numbers are smaller. So try to do it before multiplying. Okay, please pause and try number 24. And there's no diagram for this one, but it's the same process. The angle theta is in degrees, so I gave you the formula for the sector area in degrees. Please try it. Leave pi alone. Try to reduce the fraction. Okay, so for the angle theta, I am going to plug in 225 in place of theta. And that's divided by 360. And that's times pi. And that's times r squared. So r is 7. R squared is going to be 7 squared. Rewriting, these are both in the numerator, so I'm going to do 225 times pi times 7 squared. And that's divided by 360. All right, it's a little bit of work here, but 225 and 360 are both divisible by 5. So divided by 5, right here, I get 45. And 360 divided by 5, I get 72. All right, 45 and 72 are both divisible by 9. 45 divided by 9 is 5, and 72 divided by 9 is 8. All right, I don't think there's anything else we can do, but let's find out. Okay, so in the numerator, 7 squared is 49. And in the numerator, I'm going to do 5 times 49 and leave pi as is. So 5 times 49 is 245. And by the way, I didn't have to cross this out and write 49. I could have said 5 times 7 squared. Let the calculator do the work. And we still have the pi in the numerator. And that is divided by 8. Okay, and I believe that is the final answer, other than the units, which were in miles. But since r was squared, it's going to be miles squared. So I believe that's it, because they're not divisible by 2, because this is not an even number, so that's going to be it. If it's not divisible by 2, it's definitely not divisible by 8. All right, let's try number 15. So once again, for sector area, it's going to be the fraction of the circle times the area. All right, I can see here for this central angle, there's no degree symbol, and it's in terms of pi, so those are 2 hints that the units for the angle are in radians. So the fraction of the circle is going to be theta, and instead of divided by 360, I am going to divide by 2 pi. And that's times the area of a circle, which is pi r squared. Okay, and like we did in the intro, pi divided by pi cancels before I plug in any numbers. And I'm left with theta times r squared in the numerator. And that's divided by 2. All right, so you can go right to this step each time. You don't have to do this. But anyhow, plugging in for theta, I'm going to plug in 3 pi over 2 in place of theta. Okay, this is the angle right here. So theta is 3 pi over 2. And that's times r squared. And we can see the radius r from here to here equals 4. So r squared is going to be 4 squared. And that is divided by 2. Okay, so I'm going to clean this up. Let's see. Out of this whole numerator, we have 3 pi times 4 squared. Those are both in the numerator. So I am going to write 3 times pi times 4 squared. All right? And this numerator is divided by 2. And then this entire fraction is divided by 2 again. So this whole thing is divided by 2. All right. So just let the calculator do the work. Use the pi key. 3 times pi times 4 squared. Hit equals. Divided by 2. Hit equals. Divided by 2. Hit equals. All right. So 3 times pi times 4 squared equals. Take that answer, divided by 2, equals, take that answer, divided by 2, it equals 37.699 is what I get. Okay, this is in the section where you round, so look at the second decimal. If it's 5 or more, you round it up. So that's going to be 37.7. Okay, the units on the radius were in centimeters, but the radius got squared. So that's going to be centimeters squared. All right, let's go to the do not round section. Again, you want to leave pi alone and try to reduce the fraction. Actually, before we go to the do not round section, why don't you pause and try number 16. We're finding the area of this sector right here. And there's no degrees, so this is in radians. Okay, so this is in radians, and the formula is theta r squared over 2. Please try it. And you can round to 1 decimal. All right, so this angle here is our central angle. That's theta. Okay, so theta is going to equal 17 pi over 2 in place of theta. So 17 pi over 12, I should say. Okay, and that fraction is times r squared. We can see the radius right here equals 14. So r squared is going to be 14 squared. And that whole thing is divided by 2. Okay, cleaning this up here. The 14 squared is in the numerator, and so is this. So we have 17 times pi times 14 squared. All in the numerator. 17 times pi times 14 squared. So these numerators are divided by 12. And then this whole fraction is divided by 2. So on my calculator, I'm going to do 17 times pi times 14 squared. 17 times pi times 14 squared. Hit equals, divide by 12. Hit equals again, divide by 2. And I get 436.157. Okay, rounding off, you look at the second decimal. If it's 5 or more, you round it up. So 436.1 becomes 436.2. Okay, the units for radius were in yards, but the radius gets squared. So that's going to be yards squared. Okay, now we'll do one in the do not round section. You leave pi alone and you reduce the fraction. Okay, please pause and try number 21. We can see there is no degree symbol here, so this angle is in radians. And the formula for radians, sector area, theta r squared over 2. All right, let's see. In place of theta, I am going to plug in pi over 2. And that fraction is times r squared. We can see r is 10, so r squared is going to be 10 squared. And that whole thing is divided by 2. Now, cleaning this up, the pi and the 10 squared are both numerators. Okay, so I'm going to write pi times 10 squared. And these are divided by 2. And this whole fraction is divided by 2 as well. Now what you can do here is keep, change, flip. Okay, this numerator is 2. You can make it 2 over 1. So keep the numerator here, change division to multiplication, and flip 2 over 1, make it 1 over 2. Okay, remember when you divide fractions, you use keep, change, flip. So we kept this, we changed division to multiplication, and we flipped the denominator. 2 over 1 is 1 over 2. All right, let's see what we could do here. 10 squared, or 10 times 10, is 100. And 2 times 2 is 4, but wait a minute. We can reduce 100 over 2. 100 divided by 2 is just 50. And then 50 divided by 2 is just 25. So in the numerator, we canceled everything elsewhere, and we're left with pi times 25 times 1. So it's pi times 25, or just 25 pi. Okay, that's the same as 25 times pi. The units were in miles, but the radius gets squared. So that's just going to be miles squared. One quick tip, in all of these problems for sector area and radians, you're going to be dividing by 2. It's in the formula. So dividing by 2 is the same as multiplying by a half. If you want to get rid of this 2 and just put a 1/2 in the numerator in all the problems for sector area radians, you can certainly do that, and it might help you a little bit. But just remember, keep, change, flip. If you're dividing by 2, it's going to be the same as times 1/2. So you have to do this step, whether you do it early on or later on.